My name is Leah Lechovitzer. This is the Form B 2010 Calculus A-B test, Section 2, Part B, and question number 4. A squirrel starts at building A at time equals 0 and travels along a straight horizontal wire connected to building B. For 0 to 18, the squirrel's velocity is modeled by the piecewise linear function defined by the graph above. So let's get started. 1 second. Part A. At what time in the interval from 0 to 18, if any, does the squirrel change direction? And give a reason. Well, let's get this straight. Velocity is the speed and direction of an object. So when a velocity is negative, it is moving backwards. When it's positive, the object is moving forwards. So this means that the velocity changes directions when the value changes signs, meaning positive or negative. And when does it change signs? When the velocity is equal to 0. Whoops. And the velocity equals 0 at t equals 9 and t equals 15. When giving a reason for your answer on the free response form, you would word it basically how I just told you, which is that the velocity changes directions when it changes sign, which is when the velocity is equal to 0, and that occurs at t equals 9 and t equals 15. Part B. At what time interval in the interval 0 to 18 is a squirrel farthest from building A, and how far from building A is the squirrel at that time? Well, there's two methods that we can take this question, and the first one is logic. As we can see, this trapezoid is the biggest trapezoid from 0 to 9, and which means that it has traveled the farthest distance because the integral of this region would be the position of the squirrel. Also, we know it's not this in this interval over here because this trapezoid is a negative trapezoid, and that means the squirrel is moving back towards the building A, so that would mean it is not from or farthest from the building at that time. And as we can see here, this trapezoid does not recover the amount of space that is lost by, or the amount of distance that is lost by this interval. So we know that this trapezoid is the farthest distance, and it ends at t equals 9. And we know this because of disposition or displacement, which is where an object is placed, or the distance from the origin. Now, the second approach involves actual calculus. And we would do this by using a sign analysis for the velocity. Now, the points you see here are 0, 9, 15, and 18, and these are all critical points for the position function x at t. 0 and 18 are endpoints on the function, and 9 and 15 are critical points where there's maximum and minimum values. So basically, we're just going to do a sign analysis, and how we would do it if we had an actual expression is we would plug in the x values in between the critical points, and we would determine whether the value is positive or negative. But because we don't have an actual expression yet, we're going to look at the graph right here. So as you can see, from 0 to 9, it's above the x-axis, so it's positive. Over here, it's below. From 9 to 15, it's below the x-axis. And from 15 to 18, it is once again positive. So that basically means that the position graph is increasing from 0 to 9, which means it's going away from the building from 0 to 9, and it's getting close again from 9 to 15 and back farther away from 15 to 18. And as we know, when a graph is going from increasing to decreasing, that point where it changes, which is 9 in this case, is the maximum value. So t equals 9 will be the maximum value. Alright. Now, the second part of the question asks how far from building A is the squirrel at that time. And we can find it using integrals. An integral is the antiderivative of a function, and it is also the area of a graphed region. So we can find the integral of a graphed region by finding the area of that function. So as we can see, from 0 to 9, which is the maximum and the total distance we're looking for, there is a perfect trapezoid, and we can find the area of a trapezoid by using the equation 1/2 times base 1 plus base 2 times the height. And here's our trapezoid. 5 is base 1, 9 is base 2, and our height is 20. And that means our area is 140, so the squirrel has traveled 140 units of distance. Part C. Find the total distance the squirrel travels during the time interval 0 to 18. So let's clarify something. Disposition or displacement is a position of an object or the distance from the origin. But the total distance is how much distance was actually traveled over the period of time. So we can find that by using the absolute value of the integral. And I will show you how that works. So we already know that the integral of this region from 0 to 9 is 140. But this region right here is negative, and we know that distance can't be negative. So we would find the total distance traveled by taking the absolute value of that displacement, which would be the integral from 9 to 15 at v of t dt, and then the same goes for 15 to 18. Now we can find the areas of these trapezoids the same way we found the area of this trapezoid right here, and that'll be 54 from 9 to 15, and that'll be 25 from 15 to 18. And then to find the total distance traveled, you would add up all the integrals from 0 to 18, and that'll give you 215 units of distance. So the total distance traveled would be 215 units of distance. Now again, let's not confuse this with the position of the squirrel. The squirrel would have traveled a total amount of 215 units and not be at a position 215. Alright, part D. Write expressions for the squirrel's acceleration, velocity, and distance from building A that are valid for the time interval 7 to 10. So let's make something clear again. X at t is a position or distance of the squirrel, and the derivative of x at t is equal to the velocity of the squirrel, and that would mean that the double derivative of x at t is equal to the derivative of the velocity v at t, which is equal to the acceleration of the squirrel a at t. So the first and the easiest thing to start with would be a, because from 7 to 10 is just a linear function, and the derivative of a linear function is just a constant. So the derivative is just equal to the slope from 7 to 10, and we can find that using the average rate of change formula, which is the v at 10 minus v at 7 over 10 minus 7, which is equal to negative 10. So this slope is equal to negative 10, and that means a of t is equal to negative 10. Now the reason why I have the second derivative sign right here is just because the acceleration is the second derivative of the distance formula. Now that we know the slope from 7 to 10, we can find the expression for the velocity using the point slope formula. So the point slope formula is y minus y1 is equal to m times x minus x1. And what we know is that we know that m is equal to negative 10, and because that's the slope, and we know that v at 7 is equal to 20 and v at 10 is equal to negative 10. And we know this from the information that the test givers gave us on the problem. And now we just plug it in. I used v at 7 is equal to 20. You can use v at 10 is equal to negative 10 if you'd like. You should get the same answer. And you plug it in and you get y is equal to negative 10x plus 90. So I just rewrote it as v at t is equal to 90 minus 10x. And you can write it either way, whatever helps you. But for the test response, you should write v at t because that is what the question is asking for, and you should clarify that that expression is for v at t. Now, we know v at t, and we know that v at t is the derivative of x at t, so how would we find x at t? Well, that's easy. We would just use integrals. So x at t is equal to the integral of v at t, which is 90 minus 10x dt, and that integral is equal to 90t minus 5x squared plus c. Oh no, plus c! We know that x at 9 is equal to 140 because of the integral taken at part b when we were trying to find the farthest distance traveled. So we can just plug that in to the integral equation we have, and we solve for c, and we find that c is equal to 265. And then we can say that x at t is equal to 90t minus 5x squared plus 265. And that's the whole problem. Thank you, and good luck on your tests.